Hi there, it's Professor Monty, and we're looking at how to add and subtract polynomials of several variables. Okay, so we can add or subtract like terms, just like we could when we had a single variable. So remember, it has to have the same variable or variables raised to the same powers or exponents, maybe one exponent, maybe several exponents, whatever it is. It has to be the same variables to the same exponents. And then we just add or subtract the coefficients, the numbers in front, and then keep the variables. So a couple examples. I have this plus this. Now remember, this first polynomial, when I add the second polynomial, the parentheses isn't doing any operations, just separating these as two polynomials. So I can ignore all of the parentheses that I see right here, and I'm just going to add the like terms. So I have this 3xy squared. There's no other 3x, there's no other xy squared here. The number, the coefficient can be different. Notice I have a 4x squared y. That's not the same as an xy squared. They're both degree 3, but it's different exponents on the different variables. So these are not like terms. But the 2xy squared is a like term with this, so I'm going to put this right next to it. Because those are like terms. We'll go to the next one, plus 7x. Does it have a like term over here? Yeah, it has an x. Okay, so those are both x to the first. Those are like terms. Plus 2, and we have a plus 8. Those are like terms. Now, is there anything we didn't pick up? We didn't get the 4x squared y, so we'll put that in. And we got the 2xy squared, and we got the x, we got the 8. So we're good. But now I can combine like terms. Notice, don't think about the number in front, the coefficient. Everything else has to be the same. Xy squared, xy squared. Those are like terms. Add or subtract the coefficients. 3 plus 2 is 5. Keep what I had here before. Because essentially I had 3 of these and I have 2 more of these. So totally I have 5 of these, whatever these means. And then similar, we've done that before with just a single variable. So we had 7x plus 1 more x, we have 8x. These are like terms, plus 10. And then this 4x squared y didn't have anything to go with. We're going to leave it by itself. Order doesn't really matter. A lot of times we'll go in descending powers, maybe of the x's, and put this first. But it doesn't matter because addition is commutative. I'm just going to leave it this way. And we've combined all of our like terms. All right, one more example. It'll be a little simpler as far as having that many terms. But I've got this one. We've got subtraction this time. And remember, subtraction is addition of the opposite. So I'm just going to make the opposite of these. Some people like to think that is making that a -1 and then using the distributive property. However you do it, we've got this 9x squared y cubed plus 4x. That's going to be a minus 5x. And the minus 1 times minus is going to be a plus x squared y to the third. Okay, over here with addition, I just ignored the parentheses. Here I can't ignore the parentheses because this minus says, oh, that subtraction applies to everything in there. So I distribute that through, find its opposites. Now I'll combine like terms. And you may want to write them in order together. Sometimes I'll just go like this, say, hey, those are like terms. I can put those together. So I have 9 of these. I have 1 more. I have 10 of them. So I have 10 of the x squared y cubed. Notice this had to be an x squared y cubed. Number in front is the only thing that can differ. These two are also like terms. 4x minus 5x is -1x, or just minus x. Don't subtract this from this. They're not like terms. They would have to have, this would have to have an x squared y to the third, or this would have to just have an x. Okay? So don't get confused about what you can and what you can't add or subtract. They have to be like terms. The number in front can be different, but all the variables to each of their individual exponents have to be the same to be like terms. Then you can combine and simplify those.